confirm that that is indeed a minimum. Okay. So again, this goes back to the notion of our optimization where we find max and min. So this is example 4. So now we have that y is given by 30 times e to the power of x over 60 plus e to the power of a minus x over 60. Again, where x is between negative 30 and 30. So now, if this is our y prime is going to be, this is 30 times this. This is 30 or some constant times your function, so the derivative is just going to be the constant times the derivative. So your y prime is going to be 30 times, now the derivative of this is just going to be itself, e to the x over 60 times the derivative of the exponent is just going to be 1 over 60. And then plus, second part, its derivative is just going to be itself, which is e to the minus x over 60, times the derivative of the exponent, which is going to be a minus 1 over 60. Okay. Notice you can factor out 1 over 60 from both of these and change this plus to a negative because of this minus. So then this becomes 30 over 60 times e to the x over 60 minus e to the minus x over 60. So then this is 1/2 and everything else stays the same. E to the minus x over 60. Now, we have this derivative. We set it to 0. And if we solve to get rid of that constant, if you multiply both sides by 2, you get e to the x over 60 minus e to the negative x over 60 still equals 0. So then this tells us that e to the x over 60 is equal to e to the negative x over 60. Again, these two numbers are going to be equal to each other if those two exponents are equal to each other. Okay. So again, this line here is true only if those exponents are equal. So then that means that x over 60 is going to be, when is x over 60 equal to minus x over 60? So then when is x equal to minus x? So then this is only true okay, yeah. So now when is x equal to minus x? So that means x plus x is equal to 0. That means 2x is equal to 0. That means your x is 0. Okay. So again, this is only true when your x is 0. So this is our critical number. Okay. So when x is 0, we know that something happens at our function. Either it's going to be maximized, minimized, it might be neither. So if we want to find the lowest point of this function, let's see, do I have that ready? So here, again, our height is modeled by our y, where this is what we're evaluating, this wire here. So if we want to minimize it, that just means we need to find the absolute minimum. Since we have a closed bound, we have x's between this negative 30 and positive 30. Since this is a closed interval, we can just use absolute max and min. So we have our critical number x. So now we just need to find our absolute extreme, find the absolute minimum and the absolute maximum. So that just means we look at this critical number and we also look at the endpoints when x is a negative 30 and x is a positive 30. So when x is negative 30, if you plug in negative 30 in your original here, you get 67 feet. That's the height to the left. When x is 0, you get that your height is 60 feet. When your x is 30, that corresponds to 67 feet. That's the height to the right. So you see that at our critical number, when x is 0, the height is 60 feet. So that minimizes. Again, this was a notion looking at absolute extrema, absolute max and absolute min. And the reason we can talk about absolute max and min is because we have a closed interval here. If this wasn't closed, we couldn't do this notion. So, but this last part here corresponds to absolute max and min. Okay, but we wanted to find the absolute minimum. So again, if we have where the left endpoint is negative 30, the right endpoint is a positive 30, the middle is when x is 0. The question says, show that the lowest point on the wire is midway between the 2 points. And again, when x is 0 is the midway, we've shown that. So then to find how much the wire sags between the 2 points, you just evaluate this original function when your x is 0. And we have that height when x is 0 is 60 feet. Actually. So how much does the wire sag between the 2 poles? So then basically you want to look at the height here and the height here. What's that sag point? If the height of your pole is 67.7 feet and the wire sags to 60 feet, then it's going to sag from a difference. If you take 67 minus 60, the wire sags 7.7 feet here. Okay. So again, that wraps up sections 4.1, 4.2, and 4.3. Again, I think a lot of the notions for derivative, it flows naturally. You guys know how to handle derivatives, and you see that the derivative of f of e to the x is its own derivative, so it's not that difficult to handle. I mean, just another notion, but I know that you guys can do it. So again, if you have questions, I'm available via email or after class.